All right, guys, related rates, next unit. Okay, so you're going to definitely want to read this box and read what's going on there, but I'm going to go ahead and start with number 1. So if you need to pause and read through the steps and everything, kind of do that so you have an idea. Just to give you an idea, this goes back to implicit. So when we did implicit differentiation, we had x's and y's and we had multiple variables. That's what this is going to be like. Every time we take the derivative, we're going to take the derivative with respect to time. Okay, so just kind of keep that in mind. So as I read these things, I'm going to write things down. It says the radius of the sphere is increasing at a rate of 4 inches. That means the change in r per time is 4 inches per minute. That's derivative. Think about that. dr dt is the derivative, the change in r over time. Okay, so as I read the problem, I write things. Find the rate of change, which is derivative, of volume. Change in volume over time. That's what I'm finding. I'm going to put a question mark as I read. Rate of change of the volume of the sphere when the radius is 3 inches. At the moment, I take a picture. Visualize me taking a picture right there. You like that sound? That's when the radius equals 3. The key to all of this is you don't plug in any of this information until after you take the derivative. Okay, so what are we plugging it into? Well, I'm trying to find the change in volume over time, which means I have to use the volume formula. So if I write that formula, volume is 4/3 pi r cubed. So before I take the derivative of this, so you get the formula, take the derivative, then plug it in. I'm going to say it again. You get the formula, you take the derivative, and then you plug in information that you know. Okay? So before I take the derivative, I'm going to think, when I take the derivative of this, I'm going to have a dv dt. Yep, that's what we're finding. When I take the derivative of this, I'm going to have a dr dt. I know that's 4 from my information over here. Because you want to make sure you have the information you need. All right, so I take the derivative. Derivative, let me shrink this up a little bit. Derivative of v with respect to time is dv dt. The derivative over here, remember, 4/3 pi is just a constant. If I just do a side note, if I just say, what's the derivative of 4r cubed, you would say 12r squared, no problem. Remember, pi is just a constant, so I'm just going to take the exponent times the constants. So the 3 times the 4/3, the 3's are going to cancel. And so I'm going to be left with 12 pi r squared. So again, no, I did that wrong. Sorry. The 3's cancel. I even said it. So we're just going to have 4 pi r squared. I was taking the derivative of an r part. We're taking the derivative with respect to time, so I have to have a dr dt. Remember when we took the derivative of an x part, of a y part, we always needed a dy dt because we were taking the derivative with respect to time. Or in that moment, we were taking it with respect to x. So let me say it again. Anytime you take the derivative of any variable, you're going to need the dr dt, dv dt, dstd, whatever it is. Okay? Now I've taken the derivative. Now I plug in what I know. So I wrote it. So now I just plug in. dv dt is what we're finding. That's my unknown. 4 times pi times, at the moment, the radius is 3. So this sphere is growing. But we want to know at the moment that the radius is 3. Remember, a sphere is just a ball. So radius is 3. dr dt is 4. And it's increasing, so it's a positive. Because these rates can be negative when you're doing it. Calculate that all out, and you're going to get your answer. Okay, I'm going to kind of leave some of it up to you to finish off and solve. Okay, let's look at the next one. I'll use the same variables and stuff that are in the answer key so it doesn't get confusing. Okay, so observer at point A watches a balloon rise from point B. Balloon is rising at a constant rate of 3 meters per second. So let's draw this picture here. We have an observer is at point A and is watching some balloon watch as a balloon B rise from a point C. So here's the point C over here, and the balloon is rising this way. So here's this balloon, and it's going up, 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 up. We're gonna take it at one moment when the balloon is only at a certain height. Okay, so I'm just drawing a triangle essentially. I'm drawing a right triangle. Here's the balloon. We'll say it's at B, and it's going up. Okay, so I'll say that that's B. So watch as the balloon rise. The balloon is rising at a constant rate of 3 meters. So I'm going to make these X, Y, and Z. The X and Y are interchangeable. That's why I wanted to make sure I use the same variables we had before. So when it's saying that the balloon is rising at a constant rate of 3 meters per second, that's going to be the change in Y over time. So that's our dy dt equals 3. If I made this x, then it would be dx dt. But because we made it y, that's what we're going to go with. Okay, and the observer is 100 meters from point C. So the observer was at A. I'm going to get rid of that x, and I'm going to put a 100. Now think about that. You're sitting here, and here's where the balloon went off from. It's going up. This distance of 100 is never going to change. That stays consistent. So if I want, right now, I can use 100 as my x value all the time because it's not changing. This distance is changing. At some point, the balloon will be up here. Then the balloon will be up here. That's changing. Z is changing. Y is changing. Keep that in mind. Okay? I'm just going to shrink this up over here. Okay, so it says find the rate of change of the distance from A to B. So what are we finding if we're finding the distance from A to B? dz dt is what we're finding. So I'm going to put a big question mark here. Okay, when the balloon is 50 meters above ground, at the moment, I take a picture and this distance is 50. Okay. When am I going to plug that 50 in? In the end, in the end, in the end. So we're talking about distance here. Remember when we did this one, we needed an equation. Well, we had an equation. It was given to us. We have to come up with an equation. Well, if we have a right triangle, we're talking about distances. I'm going to do the Pythagorean theorem. This was originally x. So x squared plus y squared equals z squared. That's my equation. I'm going to take the derivative of that and plug in. But instead of leaving this as x squared, we know that this 100 is never going to change. It's consistently going to stay at 100. So instead of that, I'm going to just plug in 100. If you keep it as x squared, just a side note, and I take the derivative of x squared, I get 2x dx dt. What is the change in x over time? What is the change of that? It's 0. Because it's not changing. So that would be 2 times x times 0 anyway, so it's not going to make a difference. All right, so just keep that in mind. So there's my equation. I take the derivative. I don't have a lot of room here. I'm taking the derivative with respect to time. Derivative of 100 is 0. Derivative of y squared is 2y, but I'm taking it with respect to time, so I need a dy dt. Derivative of z squared is 2z dz dt. Now let's plug in what we know. At the moment that y is 50, so y is 50, dy dt was given to us, I believe. Yeah, that was our 3. And that's increasing because it's rising. That distance is getting bigger, so that dy dt is positive. Equal to 2 times z. So we come over here. We don't know what z is. Well, at the moment that y is 50, I would have to do Pythagorean theorem to find z. So if you do 100 squared plus 50 squared, you do the Pythagorean theorem. Z is going to be the square root of 12,500. So that's where that comes from. At that moment. So just be careful with that. dz dt is what we're finding. Now I can just solve that for dz dt. Act like that's a variable, and you solve from there. Okay? Using the same picture, Find the rate of change of the area. So I'm finding the change in area of that triangle per time. That's my question mark. So let's think. What is the area of a triangle? Area of a triangle is 1/2 base times height. So my area is 1/2. My base was x, my height was y. Again, the x, the 100, is not changing, so I can put that in right away. What's half of 100? 50. So I can right away put that in. You can only plug the numbers, the constants in, if it's not changing right away. Okay, again, we're still at that moment when y is 50. So it's the same picture, same information. I got my equation, I take my derivative, then I plug in. So the derivative of a is dA dt, that's what we're finding. Derivative of 50y is 50, but I just took the derivative of a y part, so it's 50 dy dt. You plug in your information again and you get your answer. I'll let you finish that using the answer key. Letter C, find the rate of change of angle of elevation. So let me redraw the triangle down here. If I just redraw this triangle, this is A, B, C, this is 100. Angle of elevation from A to B, it's that angle right there. I have to find d theta dt. Well, how am I going to get an angle? How am I going to bring in an equation if I have a right triangle? I'm going to use SOHCAHTOA. I'm going to use my trig. Now I can use any trig function I want. I can use sine, I can use cosine, but let's think about this. This was y, this was z. The only constants I can use here in my formula is the 100 because that's not changing. So I do not want to use sine here. Sine would not be a good idea because then I would have to do the derivative of this. And do you want to do quotient rule with that? If you do, feel free and go ahead. I don't want to. I want to make this easy for myself. So I'm going to use a trig function that includes 100. Okay, so I could either pick cosine or I could pick tangent. I'm going to do what the answer key did. The answer key chose tangent. So tangent of theta equals adjacent side, which is a constant. I can put that in when the 100 is not changing. Oh, oops, sorry, it's not 100. It's opposite over adjacent. And so now I can take the derivative. Remember, we're taking the derivative with respect to time. Derivative of tangent is secant squared theta times the derivative of theta, which is d theta dt. Derivative of y over 100. Remember, you could write that as 1/100th y. So it's just going to be 1 over 100 dy dt. We know dy dt. You can plug everything and solve from there. Okay. Number 3. On number 3, this is probably one of the hardest ones you're going to see. Gets a little tricky here. So I'm just write information as I know. Water runs into the Connell tank at a rate of, look at the label. The label is cubic meters per minute. That's telling me volume. Change in volume is 0.5. The tank stands point down and has a height of 4 meters. So this tank all alone as is 4 meters. But water is filling in here. So we have water. At some point it's here. At some point it's here. At some point it's here. The water level is rising. So we're just talking about that water level. The base radius is 2 of the container. But right here, when the water level is here, that radius is not 2. It's going to change each time. Okay. How fast is the water level rising, which I'm going to call that height, because we're talking about this water level, so we want to know height, which is that height there. So I'm going to say dH dt is what we're finding here. How fast is the water level rising? When the height is at 2.5. At that minute, we take a picture when the water is right here, filled up at a height of 2.5. Okay, so what are we talking about? We're talking about a volume of a cone. You would be given this formula on the AP exam. You would be given this formula on our exam. The volume of a cone is 1/3 pi r squared h. This is the formula we're going to deal with. What do? We write a formula, we take the derivative, we plug information in. There's a long way to do this and there's a short way to do this, and I'm going to show you the short way only. Think about taking the derivative. When I take the derivative of this, I get dv dt. That's fine. We have it up here. When I take the derivative of this, first of all, I would have to use product rule because I have two variables. I would get a dr dt and I would get a dh dt. The problem is were we given any information up here about dr dt? No, we were not. So this is the time you have to do a little trick. The trick is you have to come up with another equation that you can plug into this, because we're finding dh dt, which means I have to get this all in terms of h. I got to somehow substitute something in for r there. So if you think about our triangles here, we have similar triangles. We have the big triangle here in the cone. Radius is 2, height is 4. Then we have our little triangle right here where we have a height and we have a radius. So if you look, and I use similar triangles here, r over 2 equals h over 4. You can cross multiply here, and you could have done this a whole bunch of different ways. You can see that the radius is 1/2 the height. So we're finding a ratio here because of the similar triangles. That's the catch. Why am I doing this? So that I can plug that in. Now I'm going to plug this in up here into the formula. And that's why we do that. So volume equals 1/3 pi times, now I plug that in for r. And then you simplify that and take the derivative from there. Again, the reason why I'm doing that is I don't know what dr dt is. And so all I know is that we're finding dh dt and I know dv dt. So I have to find some other information to write another equation to plug in here to get it in terms of all h, because then we only have a dh dt and a dv dt. Okay, so you can finish the rest of that by looking at the answer key. Number 4, I'm going to skip completely. Okay, I want you to try that one on your own. Number 5, I will also do on here so you have an idea. I know this video is getting kind of long, so I'll just kind of go to 5 here and see. So this is a real common problem. You have the ladder leaning against the wall. And we know the length of the ladder is 17. Is that ever going to change? Is the length of the ladder going to change? If the ladder slides down to there, the ladder is still 17. So 17 here is a constant. I can use that in my formulas. It's never going to change. The length of the ladder is not changing. Top of the ladder is moving down the wall at a rate of 2 feet per second. It's going down. So again, if this ladder slides down, this distance just got smaller. So that change in distance has to be negative. So let's see, the answer key used a y and an x. So that means dy dt, the change in this distance is going down, so it's going to be negative. So that's going to be negative 2 feet per second. So now I can use that, okay? I don't know what y is. I don't know what x is. It says ladder, oh, what are we doing? A. At the moment, at the moment when the top of the ladder is 8 feet from the ground. So we're saying at that moment, we take a picture, y is going to be 8. But that ladder is sliding down. We want to know when y is 8. So here we go. We have to come up with the formula. We come up with the formula, take the derivative, plug information in. This is talking about length, so we're using Pythagorean theorem. X squared plus y squared equals z squared, but I can put in 17 squared because the length of the ladder is not changing, so I can put that constant in. I take the derivative. 2x dx dt. 2y dy dt equals the derivative of a constant is 0. So now I'm going to plug in x, dx dt, all that good stuff. What are we finding? I guess I never said. Find the rate the ladder is moving away from the house. So that's the dx dt that we're finding. Okay. So now we just plug in 2 times x. What's our x? Well, at the moment, this is 8, this is 17. You either do the Pythagorean theorem or hopefully you recognize that's a triple. So x is 15, dx dt is what we're finding. Y is 8, and then they tell us dy dt, yeah, it was -2. Solve that and you get your answer, okay? You can check the answer key. All right, last one I'm going to do for you. What are we finding? So we have the same triangle. This is 17, this is x, this is y. So we're still talking about at the moment when the top of the ladder is 8 feet. Ooh, be careful. On the top of the ladder is 8 feet from, oh no, it's still this. Still 8, okay. What are we finding? Rate of change of the angle formed by the top of the ladder and the house. So we're trying to find the change in that angle. Okay, so d theta dt is what we're finding. I'm going to put a question mark. Again, I could use any trig function here, but I want to use a trig function that involves the 17. So this time I do not want to use trig because that would involve, I would not want to use tangent because the tangent would be x over y. I don't want to mess around with taking the quotient rule and doing all of that. So I would use either cosine, that's probably, or yeah, cosine or sine, it doesn't matter. It looks like the answer key used sine. That's funny, I would have used cosine. Anyway, all right, sine of theta, we write the equation. Sine of theta equals opposite over hypotenuse. There's our equation. We take the derivative. Derivative of sine of box is cosine of box times derivative of theta equals 1/17 dx dt. And now I plug in what I know. So I plug in, what is the cosine of theta? Cosine of theta is adjacent over hypotenuse. So that's where the 8/17 comes from, because cosine of theta is a ratio. D theta dt is what we're finding. And then you got 1/17 times dx dt. Did we know dx dt from the last problem? So you just plug in what the answer was from before. So hopefully that helps a little bit. This stuff gets a little tricky. You really got to kind of take your time. Again, let me just emphasize the key. Write an equation, take the derivative, then plug in information. Worst case scenario, even on this one here, worst case scenario, you leave this as z squared. And then you think about it, when you do the derivative of z squared, you'd have a dz dt. What is the change in the ladder? 0. So you'd get a 0 right here in the exact same spot we have a 0 right now. So if you're not sure, don't plug it in. You never plug something in unless it is a constant and it's not changing. All right, keep emailing and sending us questions if you have any.